So what is time complexity, right? Or there is something called big O notation. Okay, big O notation. The way we write this is you have big O, right, like this, and then you're gonna find the operation, right? Number of operation here, like maybe one, or maybe let's say big O with n times, right? N times, or maybe you're gonna have uh, you know n square, right? So will be something like this, right? So this is called like I mean how efficient your code is, right, determined by this big O notation. Okay, big O notation. So that is what I mean. There is log n log n, right, like this 6 7 different operation. Okay, so now, right, we're going to look at one example and try to understand, okay, the importance of big O notation, or basically writing the efficient code, right? Efficient means the code which will run very fast, right? So let's take example, okay, and from that one we just try to understand. Okay, I mean, in big O notation is a big topic, right? There is the way to calculate this, like you have to do some practice, right? So uh, for now we just understand how exactly this work. Okay, so I will take this one example and let's put it in our code here, right? I mean, it's in the board here. So what I will do, I'm gonna try to put here, okay, and also I will bring the other code, right, this one. Okay, so I will just put somewhere. Can I put here maybe? Yeah, side by side. So everyone, right, just look at this code. This is a function sum up to, right, and you are passing the value n. N means when you're gonna call this function, let's say you call the function sum up to, okay, you call sub function like this, and let's say you pass maybe 5, right? What gonna happen? This function is going to add the number, right, from 1 2 3 4 until 5. Okay, it's just finding the sum of the number, right, starting from 1. So for that we use a for loop, correct? Let I equal to 1, I less than equal to n, I plus plus, and total is plus equal to I, right? The total. So you're just adding your total to this here, correct? And then finally when the loop is done, you're going to return the total. Okay, so stroke, okay, let me make it thin and change the color also, right? Fine. Okay, so this is, now tell me, right, how many operation is happening here? Anyone? How many operations are happening in this block? How many operations are there? MJ, you want to answer? MJ is here. Okay, oh, okay, MJ got out, right? So Ole Bogang, you want to answer this? How many operations we have here in this code, right?
I'm not sure how
Okay.
many operations.
Yeah.
It's equal. It's equal.
Yeah. So
Uh, uh,
basically,
have a-
mathematical calculation, right? How many times something mathematical calculation is happening? So
oh,
this is for sure, right? The operations is
it,
basically the mathematical calculations, right? So that is one, right? That is one time here, okay? But even this calculation is going to happen depends on what? Until this number, right, n time, right? As long as the it hits this condition n, this is gonna happen, right? So okay, let's take this code first. This is what? This is the just variable, okay, memory, right? One memory you have here, you storing one word, right? Somewhere you have one memory, that is fine, that is just a memory. Okay, the processing now, right? Processing is what? The mathematical calculation is a processing in your system, right? The processor will run when there is some kind of calculation, right? So how many calculation you can do, right, to complete this task? It depends on the value of n here. If you supply million, if n is a million, right, then this for loop will gonna run million times. That means this total is going to do the million times calculation, correct? That is million. So let's write this way, right? Now you can say the O, right? O is basically you have a calculation only one. I mean, even here is I plus plus, that is also calculation, right? But for now, because you know, even there is a calculation and here is a calculation, as long as you do this calculation, here is also same calculation. So we can take one calculation. Okay, just take it one, right? Because you don't need to like all the constant, right, does not matter. Okay, all the constant, like if there is same calculation many times, you just take one, and that's how we determine. Okay, the only thing will be matter, I will explain later, but for now this calculation is going to happen n times. So let's make this here, right, n, like that, something like that. Okay, let me, I mean n, right, like that, right, n times. Okay, or I can delete that. I don't know if I can. Okay, so it will be the O, order of O is n time, right? And this is basically the linear time. Okay, linear time, right? It will be this operation will be depends on this n value. But here now look at this same code. Okay, this is doing the same job, right? We have seen that yesterday in how to calculate the total, right? Oh, sorry, there is some mistake. Okay, guys, with this one. Oh, no. Let me get the code again, right? It's not there. Okay, I don't know why it added. Let's make it together like that and get this. Okay, so you see this will run also how many times? Because there is no for loop, what will gonna happen? N into n plus 1. So the one the first operation is here, n into, right, that is one time, and then second one is here, n plus 1, again one time, and then divide, right, is also one time. That's it. Total operation is 3. So we can call it O of 3. See, this, no matter how much value you provide, even 1 million, right, there will be 3 operation. That's it. Now, right, it is clear. I mean, same problem, right? Same, like this. We are doing the same, solving the same problem with two different code. Even the value of n is million, billion, trillion, does not matter, right? It will just there will be just 3 operation. That's it. But here is how much operation now? Depends on the year. N is millions, you getting million operation. The processor will run million time here, right? Now see how this code will be so efficient. I mean, you can imagine now, right? So the, if you look at here now, right, let's say go to the algorithm graph, right? Let's say graph. Okay, graph. Let's see if we can find something. Okay, I don't. maybe I'm not typing the correct way. Let's look at image. Let's call it a chart, right? Chart for time complexity. Chart of time complexity. Yeah, that is the better way, right? Okay, this one here. Okay, let's open this now, right? So even you can read here, right? The big O cheat sheet. Okay. So okay, that is almost same thing. So this O of 1 is constant. This is linear time, logarithmic time, right? So people who knows math, okay, you have an idea on this, right? This is a quadratic, n square. This is 2n and maybe factorial, right? So when you're gonna get n square, when you're gonna get 2n, when you're gonna get n log n, all that, okay? So we have looked at the constant, right? So constant does not matter, okay? What I mean is when you have, right, let's say 3, 0, 3, okay? When you have constant, this will be always 1, okay? When you have constant, that is just 1, okay? Order of 1, right? Does not matter, this is 100, 200, 300, that is one operation. So that's how we simplify the time complexity. So you know this code is very efficient, right? When something is solved with a constant, right, that code is very efficient. So let's look at the graph one time. Look at here, the horrible, right? Something is very horrible here, you know, in this color, okay? If something is n square 2n, you know, what was that, man, what was the name of that? But anyway, look that. So this is a bad, right? This color is still bad. N log n is still bad. All that. This is fair. So order of n. Look at here. Order of n is fair, not good, but this is fair, right? The constant O of 1, that is constant, right? That is very good, excellent, right? Log n is excellent. So I will show you a couple of more example, right? A couple of more means let's see. Oh, I don't know this. I don't know why this is added by the. This is all added by what you call that. This readme, right? That's not you know, should not be there. That's just a multiply, you know. Okay, I will change that one later. So order of 1 is constant is excellent best. If you can solve problem with constant, right, I mean your code is super fast, right? Okay, always good. If not log n, you know, even order of n, right, n time is still fair. I mean that is still okay. But now you start bad and horrible, worst case, right? Worst case, okay? When you have something with solving with the n square 2n and all that. But this is we are calculating, right? So let's look at the n square and maybe 2n, something like that, right? How you get that? For example, right, I can go here and then maybe, okay, let's go here, right? So let's say we have the function, okay, function, right, and call it print name, okay, simple function. And you know, I mean, you have a for loop here, right? For let I equal to maybe start from 0, right, or 1, does not matter, and I is less than what, 20, right, for example, okay, and I plus plus. So when you have loop, it will be always, when you have loop, always remember that is order of n, right? And so here we just console log. Right now I'm not going to do anything, just console log, okay? Console.log, right? Console log, and we can say print name, correct? Print name, right? So that it will gonna run how many time, right? 20 time. This is fixed 20 time, okay? But if you supply n, right, and put here n, that means it will run n time, right? Less than equal to, let's make it equal to n time, correct? So it will print name here n times. So this is one operation, right? So that is n operation. If you have for loop again, right, for loop again, same, same for loop, right? Now this is second operation. So in this situation, your time complexity will be, let's say, but maybe you're thinking how we know all this, right? You have to practice, okay? You have to, this is not something like there is no any formula, right? But you just have to understand there is like 3 4 whatever sets of things you have to remember for loop, for function, I think for a few more other operations, right? So you have to figure out in which code what you're gonna get, right? So here is one operation, and that will run n times. Here is n times. So what we're gonna do is we're gonna just say order is n plus n, right? N plus n, and that will be basically 2n, like that. That is 2n, okay? If there is 2 for loops, this code is 2n, right? So 2n means what? Let's say, how are we going to prove this, right? If this is 2n, so if you supply, let's write code, and then maybe we're going to run this in the console and try to understand, okay? So I'll just put print name, and I will pass here maybe 4, okay? So that means 4 into 2 is how much? N is 4, right? That is 8 times. So this code here, total code will be, running time will be 8, right? So let's bring this, just gonna run in the console, okay, and try to understand, or yeah. So we'll go here and paste this. I just enter, right? So look at here, 4 and 4, that is 8. So this is 2n, that is 8 times. Clear? So this print name n times, that is 4 times, and n times, that is also 4. So 2 into 4 is 8, right? Basically 2n times, okay? 2 into n times. So okay, so that is fine, right? So still right, in the terms of time complexity, even this is the 2n, the constant does not matter, right? So it will be still written as, you will see, order of n. That is what it is written, right? So this one is, I mean, it's okay, right? That code is not excellent, but it's okay, right? I mean, you can check in the graph there, okay? So when you have n is what? Fair code, right? That is just fair. So normally in our code, what we write is this one, right? Normally you will find fair one, Only sometimes we focus about the best case, right? So if you can find a way to write your function, right, which is less depends on a lot of loops, okay? But not, I mean, there will be always loops. But if you can figure out without loops, that will be best. Okay, guys. So how you gonna get n square, right? How you gonna get n square? That gonna happens with same thing, like for example, I will remove this one, right? And I will put this loop inside here. Now tell me, right? For every one, for outer loops, this is gonna run n times. Now this what is this now? Tell me now, right? I mean, this is exactly the condition of square. Okay, because let's say if this is 3, right, n is 3, for example, then 3 square means 3 into 3, right, that will be 9 times. So this code will run how many times? 9 times, correct? Yes, maybe, yes. Okay, let's check this also, because we know, right, when you have the loop, nested loops, what's going to happen? Outer loop will run one time, this will complete the cycle, again go back to this loop, this will complete the cycle. So if the n is 3, so for 3 outers there will be 3 into 3 times, so that is square, right, already. And we can prove that using our console. So let's go back and check here, try to understand that. So I'll clean up and enter, right? See, print the name n times, not n times but square time, right? I should have changed this to square. So we must understand n square. So if you look at the graph now, right, for square, there is yeah, here now look at this, that is the horrible condition. So when you have many nested loops, and for I mean right now we have just 3 here, but what gonna happen, you supply with the millions operation and you have nested loops. Can you imagine? I mean, it's gonna take forever, right? Not ever, but it will process, but even 5-10 seconds is too much to get some simple things done, right? So that's why it's called horrible code, right, with that nested loops. Okay, so we saw that, and also the 2n power, right, means that is also more horribles. All right, so we got we know that n is n squared. What else we can look at now, right? So even this logs and all that, it's okay, but you get some idea, right, how this work. Okay, and why big O complexity is very important, right, to understand. I will put this one. I think you guys can read this, right? Just give a reading, okay, one time if you get time. But the video I gave you yesterday, I mean, there will be all explanation also when you do like a regular 2 to 3 video daily basis. Just go through that, right, and try to understand. So in the interview, sometimes they will give you one problem, right, and then they're gonna ask you, okay, what will be the time complexity for this? This is, so you're gonna tell maybe the like order of n, or maybe n square, whatever, right? So you have to calculate. See, if you have nested loops, that will be order of n square. If that is just single loops, that will be always order of n. If there is no loops, then that can be the constant, right? So you have to check how many operations are there. If there is just a number, 3-4 operations, you know, and you're not getting any n, right, then that will be still the order of 1 constant time. So you just read through here, you'll get some idea. So I will put this in the, I will just put in the chat, not chat, but in the GitHub, right, later. Okay, so what else we can do now, right? Let's see. Yeah, so all these things, you know, if the order of 12 still will be 1, 500 still will be 1 constant, order of half, right, n by half, then that will be still n, means 1 by 2 multiplied by n, right? So that is still n. Okay, so the constant, if there is any number, you just remove that number, right? Keep the n, okay, value of like variables, right? If there is 2n, still will be n. 13n square still will be n square, right? N plus 1 still will be n. If there is n square plus 13n plus 8, right, still will be n square, the highest one you're going to consider, right? Okay, so when you calculate this with different operations, you can get this kind of value. So just consider, depends, if there is one n, that will be just n. if there is any square, just keep the square, right? And then based on the graph you can think about if this code is okay, efficient or not, right? So yeah, so that is all for the this is the time complexity. Like, time complexity means what? Why time complexity is very important, right? Because if we learn how to calculate all that, right, big O notation gives us a precise numeric and objective way of judging the performance of our code, okay, just by reading it or doing some calculation, right? Just writing the number of operations and figure out what is the order of operation, right? So this help us to write better code, and because as inputs gets bigger and bigger, your code will be efficient, okay, if you have better code, right? Even if there is large input, still your code will be very efficient. Let's say in the Facebook, right, there is a users or post, and you need to find something, right, from the large number of posts. If the code is written efficiently, that will run efficiently. But if there is like, let's say, nested loops or something, if that code is not efficient, then there will be problem. Always there will be problem, right? So for small, value of small n does not matter, but if you know the code you have written will be used for millions of users, right? There will be regular use for millions by millions of users, then everything matters then. Okay, now let's go back here. I think there is a couple of, okay, so let's solve the problem using while, do while, and loops, right? For loop. So sum of all the natural number, right, from 1 to n, right? So we have done that one study. Okay, 1 plus 2 plus 3 plus, you can do that, right? Very easy. You can use, let's say, you can use this. There is this way or this way, right? So the easiest will be this one. Okay, let's take this one and try to run the code. Let me comment out all this. So let's say sum of 2, right? Here I will put 2, and even you pass this number, right? Let's pass 3 and see what is the answer. Okay, sum of 2, that is capital sum, right? Because see, the order here is what? Constant, right? What is the order of this, the time complexity of this code? That is O is just 1, constant. Why? Because there is just 3 operations, 1, 2, and divide is third, right? Third operation. So O3 will be O1, right? That is constant. Okay, constant time operation, constant time operation, right? Okay, so that is so if we run this code, right, what will be our answer? So let's just run it here, F5. Can we get the result? What happened? Oh, we did not we have console log, yeah. So don't see the answer, right? F5. Okay, it did not, I don't know why it did not work. So what I will do, I'll just copy this, right, and bring to the console and see what we get. Okay, we get 6, right? 6. And even if you pass million, right, let's say you pass here maybe how much, whatever, still it will take the same time to calculate. Okay, for this one there will be no different. the calculation time will be exact same. I mean, we don't see the time here, right? We don't have any way to measure the time, but I mean, this will be, this is so large, right? It has to go in some kind of a hex code, whatever here, okay, the value. But it's just fast, okay? There is just 3 operations, whatever the number times number plus 1 and divided. 3 operation only, no million operation. Finish. Okay, so that is the, I mean, in the question here, right, it says use the for loop, but I just show you, you guys can do this with for loop. Here is a for loop, right? What is the next question? Let me check. Now, so the next question is sum of the digits, right, of number 2, 4, 5, 6. If you have digit like this, you have in your question, right, they gave you the number like 4, whatever number, 3, 4, 5, 6 number, right, together, and they will ask you to add together. How are we going to do that? The number. How are we going to do that, right? So let's take this, I mean, how are we going to solve this? Anyone has any idea how we're going to solve this?
Dev, can you hear me?
Yeah.
I believe like we first convert the number to a string and split it into an array, then convert it back to an integer and sum up each value of the array.
Okay, so you mean, let's go back here. I will comment this out, right? Okay, so for example, okay, so this, let's say function, let's write a function, right? Function, let's call it sum, okay? And here you have a number, you're gonna get n, right? So n will be, this number later when you call this console.log sum, and you pass maybe 4, 5, 6, 7 like that. Okay, let's add some small number, right? 2, so it will be easy to add, okay? Maybe one more. So 1, 2, 3, 4, 5 number there. So 4 plus 5 is 9, 9 plus 6 is 15, plus 2 will be 17, plus 1 is 18, right? So the sum is 18. Okay, so that is a number. So you are saying is let array, right? It will be when you split n dot, and you cannot split the number, right? I mean, this is not a string, so to string like that, right? String, and then to split, right? Split, and split in a space, right? I mean, with no space, yeah. Okay, fine. So let's console log now. Basically return this, okay? Return array. What we're gonna get? Console.log. I don't know why it's not working, If I just run this code, it's just printing, not giving me the, okay, here, right? Fine, here on the debug console. So we get something like this. Now you can loop through here, right? So you're gonna loop through this array. That's how you're gonna, find each number from the array and add together, right? For loop. Let I equal to 0, I is less than array dot length I plus plus. Correct? That's how we're gonna do, right?
Yeah.
Let now sum, maybe total, right? Let's call it total, because we need to store the total, and total plus equal to array square bracket I. Correct? Okay, so you you just added all, right, all the number here, and then return, just return the total, right, total. That is okay. Let's see what we get now, right? Let's run this code. Okay, so what we get now, so you added something to the string, right? We just added everything like 4 5 6 4 5 to that string here, I mean to here, right?
Didn't convert it back to an integer when adding it.
Yeah, so here you can convert to integer. So okay, so let's, I mean if you put here plus sign, right, I believe that will be integer. Okay, let's try now, right? Okay, so it is added. But now let's look at the operation here, right? This is log n, I mean order of n, right, because you have for loop. Okay, so that is still the order of n. So this this for loop depends on the length of the array and all that, right? But this is this let's see if we can optimize this code, right? Can we write this in a better way? So sorry guys, I have disturbance here. So how are we going to do that? 4 5 6 2 1 and we don't know, right, how many numbers are there, how to, I mean normally we don't know how to run these loops, how many we don't know, right? In the digits we don't know how many digits are there and how many times to run the loops. String, yeah, you can do that. When you make it array or string, there is the functions, to make all these things, but just with a number it's not possible, right? So in this case, right, what we're going to do is I will write this again. Okay, function, let's find some optimized solution. So we call it sum digit, right? Sum of maybe digits now, digits, and that will be, just call it num. Okay, so let sum, maybe sum equal to 0 here, and how we gonna find, how so while, right, because this number is something maybe like 4 5 6 2 1 so we're gonna use while loop. Okay, because we need to run this loop somehow to get each, like keep finding the, like keep checking, right, something from here. So let's say while the formula, how it's gonna work, right? Remember, if you do the modulo operator here by 10, I mean basically no, okay, let's take this number, right, 4 5 6, let's take this here and mod 10, what we get, so you're getting this remainder. See, you get 1 here, you get a remainder, right? The remainder is 1. Okay, remainder is 1, right? So we're gonna need that one, the remainder. And if you divide also, right, if you, okay, that is one thing. And then if we do division, let's say division with 10, right, what we get, so we get something like this. This is the remaining part, but we're gonna just take the, we're not gonna take the point, right? So maybe we're gonna add math.floor and take this number. Okay, so we need a remainder and plus the next one, and we keep dividing by 10 for each of them, right? So 4 5 6 2 now, next time will be 4 5 6 2 mod 10, and also there will be divide, right? Divide by 10, so you get, not mod but divide, right? That will be 10. So you have, see, you just keep moving down, you have 1 2 and keep moving back, right? Similarly the process will keep running until what time? Until n is greater than, right? I think 0. So okay, so we're gonna check here. While this num is maybe greater than 0, we're gonna do some operation. See, so when you don't know what will be the size of this, how to loop, make a for loop, then you can use a while loop, right? So as long as that number is greater than 0, do this operation. While means it will do the loop, but until this number is greater than 0. So when it go below 0, this finish, right? So now we have to do some operation here. So sum plus equal to num mod 10, right? So you know what we're gonna get now? The remainder you're gonna add to the sum. Okay, also I want have a num change to the division, right? So okay, so we're gonna do, remember we get decimal points, so I will add the math dot floor, and inside here we're gonna do num divide by 10. Clear? So we're gonna get the remaining, right? It will remove the last number. Okay, every time you divide, this num will change to the last one. I mean, there will be last one digit will be gone, right? Gone, 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 until the number become, I mean, this will only run until there is a number greater than 0. That's it. So once this loop is finished, you know, just return that sum. So now that's how we're gonna solve this problem. So what I will do, I'm gonna call this, right, and this console log this, and you pass, maybe let's pass what the same number here, right? What we have done with this, and we get what, 18 earlier, right? 18. So I'm gonna comment out this code for now. Okay, I don't know what is here. Let's see it. I don't know what is that. Comment this out and let's run this new code, right? So F5, see, we get 18. So now, right, I mean, now this is better than here. I mean, still we are using loops, because this loops will run, correct? This is gonna run, right? How many times? Like as long as this num is greater than 0. But now it's fixed time. I mean, there is limited time it's gonna run, right? It's not gonna run I mean, almost same, right? It will still run according to this one, but here we have to do a lot of operation, you know, like to splitting, then you are doing the converting to string, right? So this is still a function. So you know, in the order of particular, in the time complexity, there is also something for function. So we have to take a look at that, right? When you have many functions doing something, right, that is still the processing. Excuse me. So but anyway, there is many functions we are running. In this case we don't have, right? We just have the one loop and two operation. Here is one adding and here is dividing, right? Two operation. So you know, this is still we can call it order of n, right? Order of n, because as long as there is a loops, that will be order of n. But order of n is what, let's say this one, right? Num, yeah. So O will be, you know, n, whatever this num. So we can, right, let's think of this num times. It's not num times, you know, because this num is, if you look at the num, right, there's 45, 6 to 1. It does not run that many times. So how are we going to calculate this? The operation here is just the constant time, right? The operation is like this runs 1 time, 2 time, 3 time, 4 time. So 1, 2, 3, 4, 5 time. Maximum it runs 5 time. That's it. You know, that is all it run, right? So yeah, I think we can leave it order of 1. You know, this is still the more efficient code, you know, than other last one. But the for loop for sure that will go n time, right? There is already n. Okay guys, so I think yeah, so that was done. What else we can do? There is one more. Let's look at, right, this one. How you gonna count the number, right? If there is a question asks you, right, to count the number, count the number of digits. If there is 2, 4, 5, 6, 8, how many count is here? 1, 2, 3, 4, 5, right? So how are you going to count this digit? You can do the same thing, right? The other way here, convert to make it array and then find the length, array dot length. And you're done, right? That will give you the number of count of the digit. That is one way. But if right, they will ask you not to use the for loop, then how are we going to do that? So let's do while, right? Do while, I think. Yeah, so let's write a function, right? Function. So sometimes, you know, they ask this kind of you know, like confusing question, right? They will ask you, but we have to get some idea. Okay, I mean, when you see these things, right, you're gonna figure out. So let's say count the digit, right? Okay, and this digit you're gonna pass maybe like num. So we can call it let's say so this num, if this num is what, this num is maybe, if you pass the number in the decimal point, something like that, right? That's not gonna work. So I think we can do some checking here. Okay, let's do that. So let num equal to, we just convert to the whole number, right? How are you gonna do that? Math dot absolute abs, I believe. Yeah, just pass the num. Now so there is we have to count also, right? We need a variable called count. So let's call count equal to right now 0, and so when you start counting, right, the number may be 1. So we have to count in the beginning. So let's do it, right? How do work? Do and while, right? Do something first and then check the condition while let's say while, right, maybe this number is greater than 0. Okay, so here we're gonna say count plus equal to 1, right? 1. So once you count, right, and now, and you counted, let's say this number here, for example, we're gonna pass this 2, 4, 5, 6. You can pass any number. So I need to call the function, right? Console log console.log, and we're gonna call count digit. So let's pass this number, right? And then yeah, so that is, this will run, it will go here. So remember, we have this number, you know, this number can be 1, and even if you have dot something, right, it will just take the absolute value only. Okay, so that is the goal, right? So just imagine we have absolute number, they will tell you in the question, right? Maybe just imagine that for now. So we have count, so we counted 1 time, but how are we going to move, right? How are we going to move back? we can do the same formula, like what we did before, right? Divide, divide by 10. So we can change the norm, right? Norm equal to math dot floor and norm divide by 10. So this work, okay, this will work, right? I mean, so now it will reduce, when you divide something by 10, it will go down to this remaining number. Again, next time it will go down here, next time it will go down 24, next time will be 2, right? So that's how you keep running until this number is, as long as this number is greater than 0, you will be okay. I think, yeah, while this number is greater than 0, right? Yes, I think that we can leave it like that. And after this, right, let's return count maybe. Okay, fine. Hopefully this will work, right? So let's save this and run. F5. So we get count here, right? If I put here maybe 2 3 7 8, so run again. So I think I added 4 more, right? And you get 9 here. So it's just counting all the character, all the digit here, right? So first, even one number, it will count one time, at least. Even for one number it will count, right? Okay, so that is that was the one problem we solved. There is more, I think one more, right? What is that? Leet code. Okay, there is one for Leet code. So given an array, right, nums contain n distinct number in the range of 0 to n, return the only number in the range that is missing from the array. So you have array like this, 0 to n, right? So start from 0 1 2. So here n is the highest number, correct? So on between that 0 1, what is missing here? 2, right? So how are you going to find that 2 is missing? You just have to print 2. Output will be 2. So how are we going to do that, right? So let's go back here. I'll just copy this. Maybe no need, right? Let's go back and then find the missing in array, right? Array, something like 0 to n, right? Between 0 to n. So there is one number missing only, okay? That is what we have to find. So const, maybe I will write maybe arrow function. So missing number, right, equal to. So these are the question, right, asked in the interview, like in the, even big companies they ask, right, sometimes. So that's why I just simple questions, but try to find couple of, because see how things are done, right? And you when you guys go through that tutorial of the algorithm data structure video series, right, that 81, you'll get more idea there. Later you're gonna, when you have free time, so you just solve couple of problems on a regular basis just to improve your programming skill, right? So I will always ask, I will always encourage you to solve. Okay, even I have never done, right, before long. I mean, I did some during my class, but you just, I mean, I don't know, this bad habit or whatever, right? We just don't do the right thing, okay? And that is the problem. So I will ask you, if you get time, even 30 minutes spent, right, solving problem, okay? And that will help in the future. You'll see the difference, right? The way you approach your problem, when you're solving or writing any code, oh, okay, here is so many for loops, right? There is a better way. So that's why, the when solving or writing code, right, there is optimized way of doing things. That's why you're gonna learn tree, graph, sorting algorithms. So what are the best sorting algorithms, right? When you have millions of users and you need to sort them out, right? What algorithm will be best for that? So there are different sorting algorithm also, and you'll see in that video, right? Because I saw the name only, right? There is everything look like covering. So just look at, I mean, at least it will give you some idea, So let's say missing number, that number is an array, right? Nums, basically the array here. So let's see what we're gonna do now. How are we gonna find that, right? So let's, for example, that number, there was a 3, 0 and 1, right? 1, and missing is 2, correct? So if you add all this, right, 3 plus 0 plus 1 is how much? 4, correct? 4. And then you add everything from 0 to 3, right? So that will be 1 plus 2 plus 3, that is 6, correct? 6. So 6 minus, right, the last addition minus the first addition, 4, and that will give you 2, right? So the 2 is missing. That's how we're gonna find out, okay? Because we just look for one missing number. So if you add everything and then make a difference, right, find the difference, that will be the result. So that's what we're gonna do. So let sum, right, let store in the variable sum equal to 0, and what else we can do? I need to because this is an array, okay? So let's write for loop. For loop, let I equal to 0, I is less than nums dot length I plus plus. So this will only add, right, what, all the elements in this array, okay? So sum plus equal to nums square bracket I, right? So if there is 0, 3, it will add 3, 0 and 1, that is 4. The sum become 4 now, right? 4, okay? Okay, sum is 4. But now what we will do here now, right? We're gonna return, because we have to find the let's say what we're gonna do now, because I need to find this 6 also, right? 6, I need to add everything. So what is the length right now, right? Because there is only one number missing, okay? So the length is 1, 2, 3, correct? That is the 3. 1, 2, 3. The length is 3. I don't know if I can. Okay, let me apply, right? So if that is we're gonna use that other formula, the multiplication one, right? So 3 times 3 plus 1, that will be 4, right? 4, and divide by 2, correct? So that is 4, so that is 2, right? So this will give me 2, and that is 6. Yeah, so we're gonna get that using this formula. So nums star, right, not star, dot length, okay, that will be multiplication, right? So we're gonna put symbol here, and then we're gonna go back inside, and then nums dot length plus 1, and we're gonna divide that one. So we're gonna divide this by 2. This is the same formula, okay? The one here, Remember that shortcut way of adding? Where is that? This one, num, the length, right? The length of the array. But here if you have one number, right? For example, this number, and you want to add all from 1 2 3 4 5 until this number, right? If I put here 3, it will add 1 3 into 4, right? So 4 divided by 2 will be 2, and 2 into 3 will be 6, correct? So if you add all the number from 1 to 3, 1 plus 2 plus 3, right? So 2 and 1 is 3 plus 3 is 6. See that? Exactly, that is what we're doing, right? So the length, so whatever is the length of that array, right? Because the array has the number from starting from, let's say, from 1, basically from the 1 2 3 or 0 1 2 3 4 5 until 9 or 10, whatever, right? Maybe 20, but still in between one number is only missing. That is the point here, okay? So that's why this will work. So that is the total minus sum, right? So the missing number will be the difference. I think, yeah, that should work, so let's check this out. And okay, we're gonna console log, we're returning, so let's console log, right? Console.log missing number, and pass, maybe for now we just pass the array, right, of 3 comma 0 comma 1, and let's get the answer. F5, and we got 2 here. So if you put here, right, let's put 2 comma, and let's increase this, right, by maybe 4 comma 6. So you have 0 1 2 3 4, 5 is missing, and 6, right? So we should get 5, okay? So let's check. Run this code, and voila, here is the 5 answer, right? So this is how we're gonna find the missing number from the array. If the array is given, right, I mean there is a numbers in the sequence and one number is missing, so you have to add everything from the array and then add the total number, right? And to add total number, this is what you're gonna use. The length means what? See, look at here, length, right? 1 2 3 4 5 6. 1 2 3 4 5 6, right? There is 6, length is 6. So the number is from 0, I mean even there is a 0, right? There will be 0, because if not, this is not going to work, right? So from 0 until whatever is the length. So when you use that, when you have the last length number, last number is 6, that will be the length. If you have the last number, then you know how to find the sum of 1 to that last number, right? That's the formula. This is very useful. Okay guys, so that is all for today. Tomorrow let's see what we're going to talk, right? Tomorrow maybe, I mean, I want to maybe talk about the linked list, and maybe linked list. Yeah, I'll just talk a little bit of linked list, right? See what is linked list. Normally they don't used in our coding, the linked list, but that will help to improve the our idea, right? How exactly the, in the memory, how the data is stored and how you're going to connect to each other, right? How things are pointed somewhere, in the memory. So we're gonna, that is just the, like, some kind of interview question, right? And how you're gonna create a linked list in JavaScript. So we're gonna understand linked list, and then there is a stack and queue. That is what we're gonna do by by Wednesday, right? Thursday. So tomorrow and the Thursday. So we're gonna talk about linked list tomorrow, and then on Wednesday we just talk about stack and queue, but that is just starting, right? All these things I said you guys that all the video 2 to 3 video on daily basis, you know, watch it 1 2 time 3 time, understand and complete that whole thing. Okay, that will give you a lot more idea. And the problem from LeetCode, right? So yeah, so this is the, you know, if I bring this solution, right, let's take this in. I think I have this question open in the LeetCode. Here is, right, yeah. So if I just paste here, okay, let's run this code and see what happens. So it's accepted, right, and submit. So okay, that's, you know, see 98.92%. that is very good, right? I mean the efficiency is very good. Okay, the way this code is written is you know, beats means, I mean better than the other people, right? Beats 98.92% of the user, right, with JavaScript. But anyway, yeah, so thank you very much, and I will, you know, will continue tomorrow with something new. Let me stop here.